Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 349 maximum sum queries. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So for me, maybe there are other solutions. I'm not quite sure yet. But for me, this problem is a bit hard on the data structure. And I end up spending about half an hour on this one. But to be frank, and you could watch me go over this, I actually got the idea about this pretty quickly. But honestly, I just thought that I don't know. I still have a bit of a resistance or reluctance, if you will, to use binary index trees or segment trees. And that kind of gives away the game, right? So that's basically the hard part about this, and this is why a lot of people got it like the top people got it very quickly. I mean, you have to be a little bit careful about some stuff, but it's still, the core part of it. And the idea behind this problem is just thinking about, so let's say well, we'll get to how I came up with the binary index tree solution, or seg tree is the same idea. It's just different abstract data type, right? The idea is that the queries, because they're not live, you don't have to do them in that order. And then now, now you can pre-process them in a different way. And the idea here is that, okay, for queries, you can, there are a couple of ideas for this one, so it's a little bit tricky, or a couple of implementation details, but the core idea is not that bad, in the sense that, okay, let's say we reorder the queries and the numbers so that we process them in a certain way, right? Let's say, let's say we have something like this, but instead, instead of answering them as we get and then do a loop, obviously that's too slow. What we want to do is process the queries so that an invariant happens, right? And what do I mean by that? What I mean by that with an invariant is that we want to maintain an invariant that happens after every loop, after every some sort of operation, so that everything is held to be true. For me, the way we do it is, first by sorting the queries so that it's sorted by X and then Y. In this case, it's just, and of course you have to keep track of, of where the ordering, so that you can return the results. But effectively, we could skip that for now. We'll talk about it in code. Whoops. Now this is the queries, right? And in fact, you actually want to reverse this, right? So that you do the big queries first, because the state that we want to maintain in the world is that we want to reduce this two-dimensional problem into one-dimensional, right? And what I mean by that? That means that now, let's also process the numbers in order, right? Let's say, and we want to do this also in reverse order. So then now you have nums is, this is, 4, 3, 2, 1, right? Actually, this is pretty, so 2, I think, what's it, 3, 4, 9, 5, right? So now we sort that in order as well. This one we don't have to keep about anything, but yeah. And then the idea is that always pre-process the numbers here, right? So then now when we process, we're like, okay, we process the 4, so that means that in the things that we're considering, there's a 2 and there's a 6, right? 6 is, of course, is equal to 4 plus 2, so that we have to keep track of it somewhere so we don't lose that 4. And then now we can answer all the queries in here, right? That because here we assumes that in this caps lock, in this moment, all numbers are greater than equal to 4, right? Or x's. I'm going to x and y's just because it's like a little bit easier. So that means all x is equal to greater than 4. So that means that on this query, when we search a 1, we just have to do we just have to find we just have to find all the things that are in here where the y component is 1, right? And this is, this is y and this is total, to be clear. Okay. And so then now we get an answer for this one, and the best total is obviously 6. And then now we do the 3. The 3 is still true. Did I mess this up? Oh, should be right, but oh no, I'm just I got a little bit confused. Okay, so the 3, now we process the 3 as well, right? So then now we have, now all x is greater than 3, and then you have a thing where y is equal to 4, total is equal to 7, right? So then now and then the next thing is 2, right? So then now the no queries answer, so that's why x is greater than 2, and then we also add, y is equal to 9, total is equal to 11, right? And then now there is a query for 2. So then now we have to find all of these in which y is greater than 2 and then get the biggest total. And of course, in this case, it's going to be 11, right? Then next one, we do 1 and 5. So yeah, we can do y is equal to 5, total is equal to 6, right? So then now the next one is 3 for the query. So then that's just this suffix, right? So then now we get the max of these 3 numbers. So that's basically the idea about breaking it down this way. And if you kind of break it down this way, you'll notice that because we're always doing y is greater than some number, I don't know, c, right? And if you kind of have this in this sorted order, you always basically get the suffix max of these things. Is the query. And yeah, and that's basically the core idea. And because you're always getting suffix max, or if you kind of want to reword it, prefix max, you can do this with a binary index tree or sig tree if you want to do it that way as well. And that's basically the idea that I have, is that, that's my implementation, is that after all this processing and stuff like this, that's all we do. So now we'll go over the code. This is my binary index tree code. I actually have it pre-implemented a little bit, but then I changed it to max. I actually forgot how to change it to max, so then I had to think about it a little bit. But you can watch the live portion of it to kind of get an idea about how I kind of process on it. I would fast forward a little bit just because, to be honest, I spent a lot of time thinking that, or trying to make it not use binary index tree, but it is what it is. But yeah, let's go over the really messy code. It's only 30 lines of code, but it's kind of messy. But the idea here is that, okay, so these are just to set it up, and we set it up this way because we know that we're not going to process the queues in order. This is coordinate compression or normalization or whatever. Basically, the idea is that because the numbers can go up to 10 to the 9. Let's say we have 1,005, or that's not 5 to the bang, right? So what we want to do is we want to compress this to 4, 2, 3, basically in the order of 1, 2, 3, 4, because the actual numbers don't matter. It's just about the relative precision. So that's basically what I have here, is so that we can and this is needed for, it's not needed, but it's useful for binary index tree purposes, because then we set it to the max coordinate, right? So that's basically the idea. Let me leave this up here. I set up the binary tree to the number of unique y coordinates, and then I kind of converted the end queries. We sort the queries by, as we said, we maximum x, minimum y, though the y part doesn't actually matter, I don't think. Or the order of the y doesn't matter. We just make sure that the x coordinates is going from big to small, large to smaller. Yeah, and then we set up these events into the processing event. So we put all the X and we put the two type of events. One is a change thing event. So basically this is saying change the value of Y. We use a compressed Y to the total, and then here we just go okay. This is the index, which is the answer, the index of the query, but it's basically saying, hey, give me a lookup for Y, right? And keeping in mind that we sort this in a reverse order, so that I can do prefix max instead. And here, so then now for each key we reverse in true. So now we're going from bigger numbers to smaller number on the x-axis, and then we sort all the events. That's why I have 0 and 1, so that for the 0 we change all the numbers first, and then after we make all the changes, we can change all the we could get the prefix max of all the Y's, and that's pretty much it. The complexity is very the path compression, there's a n log n component. This is also n log n, this is q log q for the queries. All the operations are log n in this one, or technically log n plus q for the Y bits. This one is just linear. So yeah, this is also log n plus q log n plus q. So yeah, let me O of n plus q times log n plus q. Just for the sorting, to be clear, and because after that is linear, right? Or linear in the sense of, we're iterating one at a time. This is also n log n in summation, so which gets dominated by this anyway. In advertised, because basically you're sorting every number. And then this is log n. Oops, log n. This is also log n. So all these are log n, and they're going to be at most q queries. So this is in total. So this is q log n. These two for loops are not what it appears to be. So this is actually a sum of q log n because of the advertised. So yeah. So this complicated thing is your time complexity, and space is probably just linear. I mean, we don't really use anything else, right? Or linear is in n plus q. My apologies, but yeah, that's all I have for this one. Let me scroll up to my binary index tree code. Let me go over my coordinate compression, and then here's the processing, and that's pretty much all I have for this one. So yeah, let me know what you think. You can watch me solve it live in the contest. Next, remember you can skip ahead because I really did spend a long time just thinking and not really writing anything. But yeah. Okay. Maximum sum queries. How am I doing on time? 12 minutes in. Not fast, not slow. I mean, maybe a little bit slow, to be honest. Are people really done? No. Okay. I mean, respectable time, but the penalty was painful. Okay. Maximum volume up to what? Say what? I'm not getting out here early, am I? Okay. For the ith query, find a maximum value of num sub j. Okay. What is j? Oh, or index j. I think this is not bad. I think this is one of those we order the queries, process one dimension, and then or something like this, and then use like a heap type thing, right? But maybe it's easy to do it wrong. I mean, I'm cheating a little bit in the sense that I get the total like submission and whatever, and I maybe a little bit less so is that no one has gotten it. Well, okay, Chris T did, so maybe I'm wrong. So I mean, I don't think that's probably right though. I don't know the idea conceptually, but it's actually right. We'll see. Okay, so we want to sort by so we want to sort by the first value, the second value, and then the index we don't really sort, so I guess that's fine. And queries for new queries. I'm not very creative with the name. Tuple index of I guess it's technically enumerate always does weird things. I should re-bracket them, but okay. So now it's sorted by the x column, right? X's, they use nums1, nums2, and then they do xi, xyi. I feel like they don't write to be understandable, but okay. And then so now we have the queries, which is fine. And then now we want to sort tuples in this thing with zip. Just nums, I guess. We don't use nums. Okay. Okay. And then now what? Right. And then okay. Being very slow today, my mind is not processing. I get the idea, I think, if it is right. Okay, so then now let's say we have a heap. Okay, so now actually what we want is have events. Right? Am I doing it the right direction? No, I don't need events. I just need this to be a queue, maybe. I don't even need that. I could just keep an index, but I like doing it this way so I don't have to keep track. Okay, so then now for n1, n2 in nums. So basically we want to process the curve. Maybe I'm doing it in the wrong direction actually, but should be right. Everything is bigger, 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 bigger. Maybe this isn't quite right actually, now that I think about it, because when you process a number, you have to maximize the max of the sum. Maybe I'm wrong on this one. Maybe I'm thinking of something else. Okay, let's see. Because you're not just doing that. Oh, no. This should be fine. Okay. I'm processing in the wrong order, I think, but that's not hard to find. Okay. Now we're going from big to small. Now we just have to put the biggest sum on the thing. This is so annoying to get right, but it shouldn't be that bad. Larry, you could do it. Come on, Larry, I believe in you. And people are getting it. I think I know how to do it. It's just I'm just being really my head. Maybe I need to draw it out, but my head is really not thinking about it. Right. Okay. Instead of writing it in like trying to do this cool way, let me see. Num process. Okay. I don't even know if this is quite right. I don't know why I'm doing this like one time. Okay. Right. And then now, basically, for k okay. I want them in. Is that true? No, wait. Because if you go to the other one, yeah, because in that other dimension, that's not true. Right? You can. Basically, you want to get a max of. Maybe I'm. I mean, I think it's still doable, but do I need a sec tree for this? Basically, we want to get suffix max, right? Do I need sec tree for this? Okay, what am I doing? Let me think. Let's take that process again. Process the min. Okay, so by then the max will be good, but then the min, or the x will be good, and then on the y, the numbers are 10 to the 9, but we could re-index that. That is not a big issue per se. Wow, if you guys really quick if that's really use sig tree. I don't know. People are very good at sig trees. Well, maybe use a heap bit. And then when you go down the other number, the queries now on the other one will not be true. Is it really that? Is it really sig tree? If that's the case, that's just like annoying. Is there another way? Is there no non-sig tree answer? Or binary index even, but well, in that case, let's see, let's sort. That's still a binary in. Is it? Okay. Alright, I would just do it. I really thought I didn't need it, but okay, let's do. How much am I in? Like, what's my timing? I'm in about 15 minutes thinking about this. But, okay, fine. Okay, fine. We're doing weak normalization, right? Okay. This is technically good syntax, but well, I mean, it's valid syntax, maybe not good. I think technically you only need to compress one of them independently. Okay, fine. Which one is? Collections. I mean, I'm not even gonna keep that code, but okay, I just see. Okay, that's good. Alright, let me try to find my binary index tree. I guess we don't need it on X, we only need it on Y, right? So maybe I don't need it on X. Okay, fine. Okay, so then now we have a binary index tree on Y. I kind of want to okay, so what I want is actually reverse this, right? So then I don't know if this is helpful, but okay. And then now we can do it, maybe. Except for now, Y is Y is sorted the other way. So nums2 is equal to okay. Right. So now we renormalized it, but reversed the order, which is actually kind of confusing, possibly. We have to fix it for queries as well. So then now it's for index xy in this thing, and I want them in the reverse order for the x. Right? I guess the order of x, does it matter? We want to go from big to small, so yeah, okay, fine. And now we do we want x. This is confusing, so let's just change this for a second. We want to store x, y index. Okay, fine. And I am not a good person necessarily, but okay. Okay, I don't even know if this is necessary anymore, but okay. So then now we sort, we process the numbers. So, okay. Y bit is equal to n is going to be length of, should be n plus, should be n, but maybe n plus 1 is fine. And then now we process, right? Yeah, and now, okay. Okay, the multiple inputs. I'm taking my time, but well, I might have to get up and power plug because I have 29% battery left. But okay, so we do the oh, this is the length of the thing. What do we sort it by? What is this? NP is the number that we're processing, and we're sorted by the X, I suppose. So maybe put like that. Okay, so then it becomes more. No, what are you doing? Oh, that's because for this I don't sort it yet. Okay, that's fine. I just wanted to sort the contents. Okay. And then now we don't even put it here. What am I doing with the QP? I guess just like for x, y index. Oh, this is a little bit bad. Because I have to keep the sum, which is fine, but I just cannot write it like this. Okay, so then we do. We sort by, okay, X is the event. Also, this is Q. And this is n queries for whatever reason. So we want to put in Y. Oh no, we want to put in YL of Y, Y lookup of Y. And then here, okay, so that's good. We actually kind of stumbled on it relatively okay. Okay, so for is that right? Y L of Y. So this is, and this is not n. This is length of y. Geez, length of y s plus 1 maybe. Okay, and then what is this? 5 and 6. Why is it 5 plus 1? This is just feels very wrong. So the x is 3. Oh, I guess just because it also because of the query. 1, 3, and 5. That's why this is a little bit awkward. So the key is 4. 2 is not the 5th dot. Oh, because it's sorted the other way. Maybe, yeah, it's sorted the other way. Just so it's easier to read. Okay. So this is still 6 because this is 4 and 2 is 6, 3 and 4 is 7, 1 and 9. Okay, so now we're good. I was just very confused. Maybe. Actually, that was very wrong because of the order it was ordering. But okay, so let's say we sort these. We're Gucci, and now we have to process them in order. So for k and np.keys. Maybe I could have just done this to begin with, to be honest. Okay, fine. This is gonna be a grind. How much time do I have left? 51 minutes. We're fine. I mean, I'm taking it very slowly because I don't know, I'm not a smart person, but okay. Okay, so we process the numbers first. Okay, fine. So, oh, and this needs to be a min. So let's set this to infinity. Wait, what was it? Oops. Oh, there's no increase. Oh, just set. How do I do primary index tree min? Do I have to do seg tree? I forget how to do it. Maybe a seg tree. I think this is set. Oh, okay. Change maybe. Let's go to. We want the max. So actually, I've messed up here. No, value. Okay, and then here we want. Okay. Good. Okay, so I think that's good. And then now that means that for each of the numbers for y total in np of k, we set y bit of change. We change y to t, right? Possibly. It's a maybe change. Okay. Right. And then now this is a little bit awkward. Because then now for x, the way that I did this is very awkward actually. You might need to do something like write 0 for type and then 1. Okay, fine. And then we just put in the same thing. Right. Okay. Oh, this is the let's change this value and type. If type is equal to 0, then we do change. Else, then we do a query. So we do y bit dot total of y, maybe. Yeah. Okay. And then answer of v is equal to this. Yep, maybe. I think so. In theory, we're good. There may be a lot of debugging though. 6, 10, 7, 9, 9, 9. I don't know. I'm not confident about this. Also, -1. It's a little bit of. Oh. I guess I just set this to -1, really. That's actually easier than expected to fix that one because the minimum. Okay. Give it a spin. Come on, baby. Oh, huh. I spent like 15 minutes trying to think a way to not use binary index tree or set tree. So really silly. Maybe I should have. Maybe that's why. I mean, that's clearly why a lot of people got it quickly. I still took a long time anyway, but I thought that there's gonna be a more whatever thing. Yeah, thanks for watching. Hit the like button, hit the subscribe, and join me on Discord. Let me know what you think about this problem, this contest, and everything in between. Yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.